Hello everyone, welcome to SNDev, and in this video we are going to build an end-to-end XML role validator application using RAG framework with the help of Gemini Flash API, LangChain, Pinecone DB and Streamlit, and fuzzy logic for the role comparison. And this application tends to help you with the comparison of job roles from any particular PDF document against a master list defined in an XML file. I'll be showing you the demo first, and then we'll jump into the core modules and end-to-end workflow of this application, and then we'll see the code of it. Okay. And one more thing, if you are new to RAG based framework, I'll suggest you to go through any of my RAG based chatbot video to understand how RAG works and get familiar with it. I'll be I'll be giving you the link in the description. And on the other hand, if you are familiar with RAG, then this will be one of the real life use cases of RAG frameworks. All right. And I'll keep upgrading this application in future. So any suggestion you want me to add in it would be pretty helpful. Okay. All right. So now here is the demo. You could see our role validated application. Upload your XML file and the PDF file, right? Now let's see what kind of PDF file and XML file we are talking about, right? Now here is the PDF file that we have. You could see we have our company staffing overview. Here you could see precisely, we have multiple um, positions listed over here. You could see we have several software engineers, product managers, senior developers, QA tester, data scientist, then this as a table, then agile coach, operation specialist, product owner. So total we have around 11 roles in this particular PDF. Okay. And in this XML file you could see we have total of 11, and I have commented out this last 5 and I have keep this first 6. Okay, so if I use this only first 6, I'll be seeing as a incorrect XML file. Okay, and if I provide this whole XML file, I'll be seeing an correct comparison, right? So let us see that. So first I'll use this particular define roles, and here I'll use this document with roles. I'll open it, I'll start validate. Okay, now let's see. Pinecone index management, index role comparison index already exists, so we are deleting that for a fresh run. Okay, and the reason I'm deleting each and every time, because see, we are using the Pinecone free tier, so I don't want to just jacked up some waste, some, you know, I don't want to keep my Pinecone index jacked up. Okay, so every time we'll just create and we'll delete it. So give it some time for the extraction. All right, so index role comparison index deleted, waiting a few seconds for full removal. Okay, all right, so extracting roles from XML, you could see we have extracted XML roles: software engineers, project managers, senior developers, QA tester, business analyst, and data scientist. So we have provided first these 6 roles in our XML file. Now let's see our PDFs. Here you could see extracted PDF roles, QA tester, total. So here you could see total unique roles in XML was 6, as I've said, as I've told you, and the unique roles in PDF is 11. Okay, now see, role matched XML to PDF, this business analyst, data scientist, this 6. But incorrect PDF roles is this 4. Okay, there should be another one which is actually this product manager. Okay, but somehow it's not getting into the line. So the conclusion is roles in the PDF are incorrect, as there are roles that do not match in the XML files. Okay, now again let us try with the XML file where we have everything. So I'll choose this one, and my PDF is all right. So well, let me just cut it all and let me just insert again. So this one, and Under this we have this document with roles. Okay, then start validation. Now deleting for a fresh run, as we have done, as we have created this index just a second ago. So all right, so you could see extracting roles from XML. All here you could see we have these 11 roles: software engineers, project manager, and we have product owner and product manager. Okay, and initializing PDF extractor and Pinecone. All right, so processing PDF and extracting roles via Gemini. Extracted PDF roles are that. Comparing rows, generating report. You could see in the report we have total unique rows in XML 11. Total unique rows found in PDF is also 11. So rows matched, everything. Incorrect PDF rows, nothing, blank. So all rows found in the PDF match in the XML definition. So conclusion, all rows in the PDFs are correct. All right. So that's what we are going to build in this video. Okay, I'll be giving you the whole source code in the GitHub. All right, so if any of the time in the coding part of this video you feel that something is something you are not understanding, just take this help from my GitHub source to understand it. Okay, all right. All right, so now that we have seen our demo, now it will be easier for us to understand how the application works and its core module, right? So first let us understand our goal, like what we have to build, our core module. So first is, so not like first, so this is the thing that you have to build. One is of course the validation report that will present the comparison results to the user. Then our role comparer that compares the roles from XML and PDF using that fuzzy logic concept. Then of course we have to extract from PDF the main RAG concept and XML parser using ALXML tree and E tree, and our core orchestration mean our whole RAG pipeline or the whole application pipeline that will work step by step to get us our desired output. Okay, now let us see the end-to-end workflow, how it works. So it will start with this XML input and our PDF input. Okay, now simultaneously my XML input will go into my parser, my XML parser, where I'll parse this, where I'll parse master XML with LXML and elementary, which are the Python libraries to parse XML. And then it will go down to extracting defined roles from XML part. Simultaneously, my PDF will go through extract text and tables with PyMu PDF, and then chunk text with LangChain splitter. Right? Then my XML will comes to this normalize function. While I'll be using couple of normalize function like dot lower to convert all character into lowercase. Then we'll be using some function to remove the punctuation. Then we'll be using like strip function to remove any white spaces. Okay, but our PDF will go through our embedding model where we'll be generating our vector embedding for each and every chunk of our PDFs. Okay, and then here you could see we will be upsetting those embeddings to our Pinecone vector database, and so that we can retrieve the relevant chunk as per our roles. Okay, then the steps comes up to here where we have to extract roles via Gemini generative LLM API, and we are using 1.5 flash. But if you are seeing the video after August, be careful because 1.5 model will get like closed by Gemini, like by Google after August, or I think from August. So you have to use 2.5 model or Pro. Okay, and then we need to parse our extracted PDF rows, and then we'll again send them to our normalize function to again do kind of normalization part. Then we need to match with our direct match roles or our fuzzy match roles logic. Then we'll compile those results, then we'll generate the report and we'll display them in our UI. Simple. Okay. Alright, so when it comes to our fuzzy matching, our AI role validator isn't relying on just one trick. It uses principles from two foundation algorithms to handle different types of text variation. One is our Levenstein distance, or for our general similarity and our typos. And our second method is for Radcliffe overshelf, which is for our strings, like our substring matches and our abbreviations. Okay, so first let's see the first method, that what it does and how it does. Okay, so for the first one, let me name it as Levenstein distance, or LD. Okay, so the first one we have our Levenstein distance, which is often called as edit distance. So this algorithm quantifies the similarity by measuring the minimum number of single character edits, like insertion, deletion, or substitution, requires to transform one entire string into another. Okay, the lower the distance, the higher the similarity, right? So in our application, as we will be using fuzzy woogie, so fuzzy woogie dot fudge dot ratio, this particular keyword will be using to use this particular algorithm. Okay, so this is a great way to apply this, and it calculates a score out of 100 based on this edit distance. And you will be seeing in our video, will be mention a threshold of 80. Okay, and so any similarity score above 80 will be called as our like similar string. Okay, now let's see it by one example. Okay, like how it does with the calculation. Like the formula is this similarity percentage. Okay, so let's say we have a role as tester. Okay, and let's say by mistake of typo we have this TATER. Okay, so how this particular algorithm calculates? So as I told you before, that it uses a concept called edits, and these edits can be as insertion, can be as substitution, can be as the deletion. Okay, so let's us check, right? So we have T and T, so we don't need no edit. E and E, no need to edit. This S and A, need of one edit. Again, this TR are all same, so we need our edit is required 1, right? So our similarity percentage would be our length of the string, which is around 6, right? So to calculate, it would be 6 minus 1, our edit length, like our total length minus edit length by this 6. Wait, what's happening? Okay, so this 6 minus 1 by 6 into our 100%. Okay, now 5 by 6, this generally will comes out with the percentage of 80. If you do that, 2 3 2 5 250. Okay, so we have over here 250 by 3, so we have around 80, around 82 and 3 kind of percentage, so which is above our 80%, right? But the problem arises when we are using a string like this, software engineer. Okay, software engineer. So this is our, let's say this is our XML string, and in our PDF we have this engineer. This two string means the same, but if we use our this Levenstein distance algorithm, we won't be getting 80%, because if you see, we have around how many we have here, around 17 letter, and here we have 4 fours are 8, 4s are 9 with combining this, so 3 4s are 12 and 1s are 13, right? So we need, so one change is required, so we need, so the requires of edits are these 5, right? So this substitution of dot to I and this insertion of this 4, so the edit would be 5. So to calculate 17 minus 5 by 17 into 100, let me calculate it once. So if I calculate this, we have 100 by 17, so this gives us the value of 70.5%, so which is below 80%, but actually in the real life these two string means the same. So that's where we comes with the Radcliffe overshelf. Okay, and this algorithm or this logic simply says that we need to check the substring matches. Okay, so the crucial cases like this of abbreviations, or when one role name is a clear subset of another, we turn to the principle of this Radcliffe overshelf algorithm. Okay, and this algorithm works by finding the longest common continuous substring and then it recursively analyzing the non-matching parts. Okay, so in our application, let's say for the 2, our fuzzy wuzzy dot fuzzy dot, when we are using this partial ratio keyword, that's when we are using this particular concept. Okay, and this function specifically finds the best possible match of the shorter string within any substring of the longer string that has the same length, right? So we have this, let me just write it again. So we have software engineer and we have software engineer dot, which is a kind of an abbreviation. So this is for the XML and this is for the PDF, right? So as per the formula you could see over here, just let me just write it over there again. Okay, so sub pass our two string s1 s2 2 into similar character by length of s1 plus length of sub 1. Now what this means, right? So our first character has 17 character, our first word has 17 character, second word has around 13 character, right? So how many letter matches? So our shortest string consists of 13, right? And this 13 is under this 17 letters, under this 17 letters, right? So the first thing we need to check that how many substring we can generate with this 13 characters out of this 17 character word. So let me show you what I'm trying to say. So one thing you can generate is this software eng, right? One thing you can get. Another thing is this software engine. So these all of 13 characters, right? You could see 4 4s are 8, 4s are 12, this blank space 13, 4 4s are this blank space 8, 4s are 12, and this n 13. So how many can we generate? So so that's the formula would be 13 minus 3 plus 1. So total would be 5. Okay, so we will be having this kind of string, total number of 5. So but now let's calculate with this first one, software eng, right? So how many letters we have over here? 12, around 13 character, right? But problem comes that how many particular characters we are matching. You could see we are actually matching 12 characters. This S, O, F, T, W, R, E and E, N, G, I. Right, now let's match it. So we have this software engineer, and again we have this software, and we have Eng, then we have software Eng. Right, so we are not taking with this, we are handling with this. So let me just do the name whatsoever, software and software. Sorry for the handwriting. Okay, so how many characters are matching? This 8, this 9 and this 3, so 12 characters are matching. So our similarity, so our similar index or character is 12. Right, so in this formula, this in this similarity character we get 12. Okay, now we have this length of S1 and length of S2. This length of S1 signifies our shortest length. So S1 signifies our shortest length, mean that we have to, because that we have found in our PDF. So our shortest length, and this sub one is substring. Right, so what's the length? This length is 13, this is also 13, right? This is 13, this is 13 as well. And okay, so our final calculation would be this S1 and S2, 2 into, we got how much, 12, right? So 2 into 12 by 13 plus 13, which is 24 by 26. So if I calculate this, 24 by 26 is coming as 92%. Like it's actually 0.92, but after multiplying with percent we are getting is 92%. But this is for the first string, but we'll be having 5 string like this, right? So after comparing this 5 string, for which one we'll be having, like most we'll be taking there, and most probably we'll be getting 90. So this 2 string as per this logic will be considered as similar, right? So that's the under the hood logic and the concept that's been working. Okay, so yeah, that's what I have to say before we get into the code. So now let's just dive into the code and just program the whole application. Okay, so first we need to get our important API keys, right? So we'll be needing our Gemini API key. So you can get that from this URL, aistudio.google.com/API key. Sign in your Google account and get your free API key from here. Okay, then for our vector database we are using Pinecone database. So sign in and get your API key, and at first you will be seeing a blank in this index. Okay, so don't worry, we'll be creating the index for the runtime. Okay, now after that we need to create a folder. Before folder we need to activate our virtual environment. Okay, I have already created one, but just to show you, I'll be showing you the command. So before that, let us create the folder where we will be creating our application. Okay, so let me name it as XML Role Validator. Right, I'll create this folder, you could see over here. Okay, and now we need to get inside of this folder. So XML Role Validator. Okay, all right, so now let us first create a readme md file, so that if I need to tell you, I'll be creating that over here. Okay, don't worry. So readme.md. okay, now the first thing for us is to create our virtual environment, right? So So for create our virtual environment, the simple VNV I'll be using. So Python -m venv and my-env. You might use UV or Poetry or PPNV or Conda, but I feel these are pretty much simple and easy to use. Of course, it takes some time to install those dependencies, but still. Now we need to activate. So activate VNV, right? So for that, I'll be using my-env slash scripts slash activate. Okay, so I'll simply copy this command and I'll paste it over here. So for that I need to get out of this XML role. I'll paste it. I'll activate my environment. I'll again get inside of my folder. Okay, now first thing we need to do, we need to have a .env file. So .env, here I'll simply paste my API keys. Alright, so the API keys I'll be needing, it should be Google API key and Pinecone API key. Okay, just place your API key over here. After that, important thing, always have a .gitignore file, .gitignore, and write your .env. Like write all the files or folder that you don't want to push into the GitHub. Okay, now we'll save it. After that, we'll create our requirements.txt. So create our requirements.txt, right? Here we'll be writing all those libraries that we need to install for our application. Okay, so as we are using XML files, so to kind of parse our XML file, we'll be needing XML. Okay, for our processing our PDFs, we'll be needing PyPDF2. To process our environment variables, we'll be needing python.env. Then as we are using Gemini AI, so we'll be needing Google Generative AI. We'll be needing Pinecone-client. We'll be needing fuzzy woozy. Okay, fuzzy woozy, and the reason of that as so fuzzy woozy will be needing Python 11. So Levenstein and Fitch, and this last of these three dependencies will be helping us to use our fuzzy logics, and that is the main concept that we'll be using to compare our PDF documents and our XML documents. Alright, if you need some more information, get through how fuzzy logic works and how these libraries work. Alright, so after that we need to run this command, and to run this command we'll be using this simple command, pip install -r requirements.txt. okay, after you will installing everything, you will be ready for the code. Okay, now after getting our API key, after creating the virtual environment, then after installing all the dependencies, our first step would be to kind of create the core configuration file. Okay, so for that we'll create a folder name as config. Under that I'll create a file as config.py. okay, here I'll kind of import my all environment variables and other important variables. Okay, so first import OS, simple. Then we need from .env import load.env. Simply call the load.env function. Then what we need our Google API key. So Google API key os.getEnv. Here we'll simply pass our Google API key. Okay, same Pinecone API key. Okay, Pinecone. Wait, Pinecone API key. All right. Okay, so now as you could see that in my this Pinecone index, you could see we have this index name. So we need to create our index with a particular name. Right now you can also mention that name in your .env file, and also you can make it a piece of default. So I'll be showing you both. Okay, so let's say Pinecone index name. Okay, simple. Again, os.getEnv. Here if you just pass this Pinecone underscore index name, it will simply take the index name that you are mentioned in your .env file, but in our case we haven't, so we'll simply add a simple by default name, so that if by mistake we didn't mention our any environment variables, I should still get some default name. Okay, so role comparison index. Okay, after that you could know that in generally our RAG based application, where we need to kind of get the chunk from our PDA, we have to mention the chunk size, like our PDF chunk size and the PDF chunk overlap, and I thought why not mention this over here. Okay, so PDF chunk size, and I'll be using PDF chunk overlap. Okay, now how to get it? Simple int, I'll use os.getEnv. Here I'll simply pass the value. We can also mention it in our .env file, or we can simply give a by default. I'll just copy this, I'll paste it over here. I'll copy this one, I'll just paste it over here, and for the chunk size I'll be keeping it as 100. Okay, so after that we need to create another variable as role extraction prompt. Okay, and this will help us to kind of mention that how our application should work as per the given prompt. Okay, so getEnv, again simple. I could have mentioned it in the .env file, but I wouldn't. I'll just simply give a by default. Okay, now for the prompt, I give the prompt over here. Okay, and for now I'll keep the prompt over here. So all right, let me just shape it properly. Okay, all right, so we have our role extraction prompt ready. Now after that we'll be needing another thing, and this is our fuzzy match threshold. Like, as we are using fuzzy logic to kind of match our XML and our PDF roles, so let's say fuzzy match threshold. Okay, and what this means, this simply means that above which threshold my application will consider a particular PDF and particular XML that okay, these both roles are matched. Okay, so you can mention it, or by default I'll be keeping it as 80. Okay, and as it's an integer, so we have to take all this os.getEnv under this int function. Okay, that's being said, we are done with our core configuration. Now we need to create our Gemini client and our Pinecone client. Okay. All right. So we have set up our project and configured our API keys, right? Now it's time to build the heart of our AI integration, which is the Gemini client.py. And this file will kind of act as our direct communication bridge with our Google's powerful Gemini models for both kind of generating text and creating those crucial embeddings for our RAG systems, right? So let me first create a folder. So I'll create a folder as, let's say, SQL, not SQL, like SRC. Okay, SRC, under which I'll be storing all of my important modules. Okay, so the first file that I'll be creating over here, which should be Gemini client.py. All right, so first let me just import couple of libraries. So first, let's say import google.generative AI, and for a simple alias I'll be using GenAI. Okay, then which is I am using for the first time, which is google dot again generative AI. Here I'll be importing not with dot types. I'll import harm category and harm block threshold. Okay, then from config I'll need to import my Google API key. All right, so this harm category and harm block threshold, we'll talk about this kind of safety settings in a moment. Okay, so crucially we need to import our Google API key from this config.py. Okay, then we need to this line GenAI dot let's say configure we need to pass our API key over here, which will be this Google API key. Okay, and this is pretty much essential, as this is where we tell the Google generative AI library that which API key to use for our interactions. Okay, all right, so after that we need to create our Gemini client class, right? So if any of you have done the object oriented programming, you know that to kind of create a reusable component for an object, we create a blueprint which is called class, right? And we'll be using that same concept. We'll be creating a class of our Gemini client, and we'll create a blueprint that how that Gemini client should work. Okay, so let's say, let me first name it Gemini client. Right now, in object oriented programming, when you are creating a class, the first thing we need to do that we need to create a default constructor. Okay, and in Python we do that using this def init. Okay, now we need to pass our self parameter, and we'll pass the model name over here. Okay, in the model name here I'll be passing Gemini 1.5 flash. And one important thing, that this Gemini 1.5, this whole model going to be closed from Gemini by like within the August 31st, I guess. Okay, so if you are watching the video after August, don't use Gemini 1.5, use Gemini 2.5 or Gemini Pro. Okay, all right, so after that we need to initialize our this class. So for that self dot model. Okay, here we'll call our GenAI dot generative model. Okay, generative model, under which we need to pass our model name. So model name, we have this Gemini 1.5 flash. Okay, all right, so now you see we need to kind of configure the safety settings. So let me first insert those safety settings, and then I'll kind of try to explain you. Okay, so safety settings, and here we'll be having 4 kind of safety settings. Okay, so the first would be, let me first add them. So I need to add the category of which, so I'll be using this harm category dot harm category One will be for harassment. Okay, then I need to pass the threshold, and for that I need to use block threshold. I'll be using block none. Okay, and now let us understand what is this thing. Okay, so this is a kind of a point of choice that see, Gemini models have some default safety settings that enable to filter out some harmful content. Let's imagine that for an application like our role validator, which deals with professional document text, these defaults are usually perfect fine. However, if you are building an application, where you might encounter content that could be bit of sexual or bit of violent, by default these filters, or if you need to be extremely strict, you can override these settings. Okay, but in this specific code we have set all safety categories to block none. So this means that we are essentially telling the model that not to block content based on these categories. Okay, because we are not having any kind of violent or inappropriate text in our XML or in our PDF files. Okay, but if future you want to build any kind of chatbot that needs some strict settings, you might see to use this kind of settings. Okay, all right, so what I'll do after that, I'll simply copy this and I'll paste that 4 times, and I'll just use 4 kind of safety check. Okay, the first is for the harassment. Second one I'll be using for, let's say, hate speech. Okay, hate speech, it will be same for that. I just need to change this category over here. After that we'll be using sexually explicit content. So sexually explicit, then we'll be using dangerous content. So dangerous content, this 4 would be pretty much enough. All right, okay, so now our next is our generate text and our embed text. Okay, like as I told you before, that we are creating this class, and every class should have its some feature to kind of describe this class activity or its behavior. So we'll be having two method or two function. One will be to generating text and one will be to embed text, right? So let me first create those function. Def generate text, where I'll be giving this prompt self, and the prompt would be a string, and I'll use that to a string. Okay, I'll simply use pass. Then I need to create another function which would be embed text. So embed text, again I'll pass a self, and for the text it would be string. I need to point it to string as well, not string, because embed would be in a form of list, right? Because this will be our embed vectors, so this string should point towards the list. Then I'll use pass. Okay, now we need to create this function. Okay, so now next is our generate text method, right? So let me just clear this text pass. All right, so let me first give it a comment to kind of show, to kind of let any other developers to know that what this method will do. It's always the best practice. So generates text using the Gemini model. Okay, I'll kind of also suggest you to use this kind of commands kind of before you start writing a function definition. Okay, of course, for our safety check we'll be using our try catch block. So try, we'll use our except. So except exception as e, and here we will simply print an f string to show that if anything goes wrong, there should be a simple error to show our user, right? So error generating text with Gemini. and we'll simply pass the E, where we are kind of storing that exception. And so that our application just doesn't break, so we need to pass a blank string, like an empty string. So try except. Now we need to clear the try. What we'll do, after taking that prompt in this function, we need to call our Gemini. We need to pass this prompt to our Gemini model, right? So for that, I'll simply call the self.model.generate content. So I'll be passing this prompt to my model, and what I'll be passing the prompt. Okay, and I'll be storing this response into a response variable. So response. Okay, so now I got the generated content in this response. Okay, now if response dot candidates is there, and this candidates kind of signifies that our Gemini model has predicted some prediction, or it has generated some prediction. So that's why I'll be calling it as if response dot candidates. I'll simply return the response dot text. All right, else I'll show an error that Gemini API returned no candidates. Also, as I said earlier, we always should return an empty string in case of any problem, so that our application just doesn't break. Okay. All right, it's done. Our generated text function is done. All right. So now for this embed text method, again we'll be writing a simple comment that generates embedding using Google model. Okay, and then we'll simply create a try catch block. So try use exception as E, right? Here we'll simply print a simple error string. So f string error in embedding text. Okay, if we get an error, we should always return what we should always return what we are expecting, right? So we'll be returning an empty string because we are accepting an string, and we should provide a string. So if in case there is some error, we should always provide that empty string, so that our application just doesn't breaks off in the middle. Okay, so let's come into the main logic. Here we'll simply call our embedding model, right? So let's say GenAI dot, I'll call the model. So embed content, embed will be underscore embed, sorry, embed content. Okay, and here I need to pass a parameter of the name of the model, right? So under quotation models slash embedding 001, which is the one of the best Google's embedding model. Okay, and we also need to pass the context in the format of text, as we are passing list of text. So list text. Okay, and we need to store this whole response in a variable which will be response. Done. All right, so after that we need to check that if the response that we have received is perfect or not. So if we got the response, and as every response will contain that embedding, so and we got the embedding under this response or not. If response and embedding, sorry, embedding, okay, in the provided response, come on, in response. If is that, then we need to extract that embedding from the response. Okay, so in a variable called embedding, I'll simply extract that. So response with embedding. Okay, now after getting this embedding, as we are kind of calling an API of this embedding 001, and sometimes this API might give some, some unwanted formats, so we should always use some safety check that the given response is in the proper format or not. And for that we'll be using this couple of line of code. We'll be using that if is instance, and we'll be passing our embedding and the list of our document chunk, and we'll check it into this for loop of x in all the embeddings with this format of for float and int. If the format satisfies, and we'll simply return the embedding. If by chance that format doesn't satisfy, and that format has an embedding with a list with a length of 1, then we'll be returning the first index of that embedding. Okay, so if after that safety check, we simply need to close that if else statement. So else print let's say unexpected embedding format. Okay, and just for the debug typing, we need to always print the unexpected format that we have received. Okay, so type embedding, like in what types of format we have received that embedding with embedding. Okay, and again, as we have received the wrong format, so we should return an empty list. Okay, done. So our embed method is also done. Alright, so in our last segment we have built the GeminiClient.py file that will help us to generate those embedding vectors. Right now, to store this embedding vectors, we need to have a vector database, and we'll be using Pinecone for this video. And we won't be just storing those. We need to create index in our Pinecone. We need to upload those embedding vectors to Pinecone. We need to search some semantic searches throughout our vector store to get some relevant chunks, right? And then we need to delete the query, right? So for that, I'll be creating a class, and of course for that I'll need to create a file first. So let's say Pinecone client.py file. So this will behave as a tool to interact with my Pinecone database. So let us first import those libraries from Pinecone. I need to import Pinecone first, then index serverless page. And why serverless page? Because we are using the free tier of Pinecone, right? So here we need to mention that which region, which cloud we are using for the free tier. So for that we need to import this serverless page. All right, so as we'll be calling Pinecone API key, so there is always chance for some error in our API calls. So to handle them, Pinecone.exception, we need to import our Pinecone API exception. Okay, now for the index name, for the API name, we need to get that from our config file. So config.config, import our Pinecone API key and our Pinecone index name. Okay, then we need to import time, because we need to give Pinecone some time to set up our index, right? So for that, okay, so now we need to define our class. So class Pinecone client. Okay, so as I explained earlier, that this class will behave as a blueprint of our Pinecone client object, right? So every class should have its default constructor that will initialize this variable. So for that, let us initialize this class first. So def init, here we'll pass the self. Here then we need to pass the index name. So index name, which is of course Pinecone index name, and we need to pass the dimension. So dimension, which is 768. And you might ask why 768 precisely, because we are using Google's embedding 001 model, and that model precisely gives us an embedding vectors of the dimension of 768. So for that we need to specify that, okay, we'll be having these dimensions of vector, so create an index so that it can store with that dimension, right? Now we need to simply initialize our those variables. So self.pc mean our Pinecone client. Our Pinecone will simply pass our API key with Pinecone API key. Okay, then our index name, so self dot index name will pass index name, not comma. Okay, then our dimension, so self dot dimension. This is like the normal simply object oriented programming in Python. Okay, then self dot index. Here we need to initialize our index, so index of self dot my get or create index function. Okay, so this self dot get underscore or underscore create underscore index function will behave as a private method to kind of handle the logic of making sure that our Pinecone index is, you know, I'm ready to go. Okay, so after initializing that, every class has some is method that defines its attributes or its features, right? So let us first mention those method or those function. One would be get or create index. Okay, we'll simply write a pass, then we need to upsert those vectors. So after vectors pass, then after upserting vectors we will be needing to query vectors, right? We need to search through our vectors, so query vectors. Again, let me just pass through that, then delete all index. Okay, delete all index of like all the index that we have created, pass. Okay, now we need to fill these functions. Okay, all right, so now for this get or create index function, what we need to do, we first need to pass the parameter self, right? Now we need, the first thing that we need to check if the index exists, right? So we should always use this kind of safety check that the index that I want to create, if it's already been there or not, right? So for that, let me first initialize the try except block. So try except as, except there will be exception as e. All right, and we'll simply print something that error listing Pinecone indexes. Okay, then just pass the e. Okay, and yeah, one thing, it won't be just simple exception, it will be that exception that we have imported from our Pinecone. So Pinecone API exception. Okay, and we'll simply return raise, and we'll raise the error. Okay, and we'll stop the execution for it. Okay, now in this try block, what we'll do, we'll in our existing indexes variable, in this indexes, okay, I'll just call my list index function from my Pinecone. Okay, so self dot pc, which is my Pinecone, dot list those indexes right? And I want the name of them, so names. Okay, so now in this existing indexes, I have all the indexes that I have already have in my Pinecone database. Okay, so after that, come over here, we'll create an if self dot that particular index name, not in this existing indexes, mean the index that I want to create, if it is not being created before, then and only let me just create a statement to make sure to know. So let's say creating Pinecone indexes. Okay, and let us just put the name of that, so index name. Okay, so if the index name hasn't been created, then we'll have to create the index now, right? So again, try except with Pinecone API execution as E, simply an F string, error, creating index, pass the E, that's it, then simply raise and it will stop the execution of it. Okay, except Pinecone API exception as E. Alright, so over here, what we'll do, as we are in this if block, because the index name hasn't been created, so we need to create the we need to create the index, right? So self dot my Pinecone vector, then this function, this create index, will be using, and within that we need to pass those parameters. So name would be self dot index name, of course, then dimension would be self dot dimension, right? Metric would be cosine, cause we need to calculate our vector embeddings among them, right? So cosine is the most kind of recommended for our Google embedding. And for our spec, we need to call our serverless spec, where we need to pass our cloud name, which is AWS, and our region name, which is, by default we generally get US East -1. Okay, and after that we'll simply create a statement to show that that index is creating. So for that, index, which index, this self dot index name created. Oh no, it will be like this, and here I need to make it single quotation. Alright, so index now is created. Now, as I said earlier, we need to give our Pinecone some time to set up and initialize our index. So we need to give some time to our Pinecone database, right? So for that, we'll run a while loop, while not self.pc dot, we need to describe the index situation. So describe index, and now which index, self.index name, simple, and we need to get the status of the index. Okay, it would be a status. So status, let me put ready. So if the status is not ready, like you could see, while not the index is ready, so we need to give that time sleep. Okay, we'll be giving it 1 second of time to set up the index. Okay, all right, so this if blocks handles the situation of that if that index of that particular name hasn't been created. Now for the else block, we'll take care of the situation where that index is already being created, right? So else, here here we'll simply print a message, but we still have to perform that while loop check. Okay, so let's say I'll just um, take this line and I'll just copy paste it over here. I'll say that Pinecone index exist, right? And after that, in my try and accept Pinecone API exception as E, simply print error describing index, then simply raise. Okay, this is for the safety check. Now, as I said, that if if index is already been there, we need to see that if this index is ready for the use or not, and if it's not, we just will be still giving it some time to initialize that index. Okay, so if not, that self dot pc dot describe index is ready, so describe index of name of self dot index name of status ready. So that already created index is still not ready, then we'll be giving it some more time to get ready. Okay, so while not in, I'll just copy this while loop from here. I'll just copy it and I'll just paste it over here. Okay, while this will be under this. Okay, so while not self dot pc dot describe index self dot index name status ready, and we'll be giving it 1 second of time. All right, then finally we just need to return, right? So what will return? We'll return our index. So self dot pc dot our index with our self dot index name. Okay, all right, so our function of get index and create index is done. Now we need to create this upsert vectors, query vectors, and delete all index function. Okay, so now that we have a ready index, so now let's see how we can upsert the vectors to our vector database, right? So first we need to pass some self parameter with the vectors. Okay, and every vectors are in the form of a list. Okay, and where every index of that vectors list combined with the id, that particular data's embedding, and some metadata. Okay, so let me just give some comment over here. So let's say upserts vectors to Pinecone. Okay, all right, so if there is no vectors, so if not vectors, what we'll do, we'll simply print something. Let's say no vectors to upsert or upload, something like that. Okay, then we'll simply return, not return, return, right? And if we have something, so we'll use a try except block. So except with Pinecone API execution, let's say print upserting vectors with E, and we'll simply stop the execution after that. We don't need to stop it because all right, so okay, you know what, here we don't need to stop the execution. Okay, after that we need to add another exception, except cause the previous one for our Pinecone API and this one for just normal our backend API, for like for our backend fallout. Okay, so as E print an error occurred, which error? The E. All right, okay, So now in this try block, we'll simply need to upsert, right? So for that we'll use save.index.upsert. Right here we'll pass our vectors with vectors. Okay, then just for some showcase that what's happening, we'll write that upserted vectors to Pinecone index. All right, so this part is done. Now our query vectors. Okay, and this query vectors is how we find the most relevant chunks in our PDF. Okay, so first we need to pass some parameters again. So self, and we'll be passing our query embedding. So query embedding, which happens to be a list, and then our top k value, our top k, which is int of 3, and we tends to make it a list. Okay, and this top k value tells our Pinecone that how many of the most similar vectors it should return. Okay, so after that we'll again initialize the try except block. So try except Pinecone API execution as E. I'll just simply returning a blank list. Okay, I don't want to waste my time on like those printing those statements again and again. And then again another except exception as E, simple return the blank list. All right, and over here what I'll do, will in my results I'll simply call my query function. So self dot my index dot, I'll run a query. Okay, and in this query I need to pass my query embedding. So in this vector I'll pass my query embedding and the amount of relevant chunk that I want to retrieve. So top k would be this top k, and one thing that we need to make this include metadata up to true, and the reason of that is so that we can get back the content of our extracted chunks like that we have stored. Okay, so after that we'll return our results dot matches. All right, we'll simply save it and this will work. All right, there's an error, let's see, it's not closed. 63. Okay, this one query vectors, this ends over here, so yeah, sure it will be an right. All right, now we need to delete our all vectors, and the reason I am kind of creating this function because see, we are using the Pinecone free tier, right? So I don't want to just jacked up the place by just wasting those indexes. So after the work is done, this index should be deleted. Okay, so I'll pass the self. It will be a pretty simple function. It will be so try okay, here I'll just simply print that error deleting vectors. Okay, then exception as E. Here I'll print another statement. Let's say an unexpected error occurred. All right, and also over here I need to provide that variable E. All right, now to simply delete our vectors, what we'll do, will self dot index dot delete. All right, here we need to pass delete would be okay. So here we are kind of deleting everything. Okay, all right. So now after that we need to create our utils.py that will consist logic for our. All right, so our deleting index is done, so our Pinecone client is done now. All right, so we have our Gemini client and our Pinecone client, and now we need to create our document processing logics files, right? But before that I need to have three more important but small functions. Okay, and I'll be calling them as my helper functions, and I'll be keeping them in my utils.py. So utils.py. all right, here what we'll do here, let us first import me relational let me first import me regular expression, so RE, and as we have installed fuzzy wuzzy, so from fuzzy wuzzy I'll import fuz fuzz. Okay, now what we'll do here, we'll be needing three important but small functions. Number one is normalize the role, then we need our fuzzy match. Okay, then we need our chunk text, our chunk text. All right, okay, so why do we need normalization role? Let me just give you some example. Let's say in my let's say in my PDFs, right, in my PDF I have a role as this software. Okay, and in my XML I have something like this software, but these both are same, like the meaning wise same, but as the first one has a capital A and the second one has a small a, this might differ. So for that we need to make sure that every word has to be normalized first, right? So that's why let's say if not, but first we need to check that do we have the role or not, because we need to pass the roles, right? So let me first pass role name, which will be of course in the format of string, and this whole function would provide would return a string in format, so string. Okay, so if we don't have the string, so if is instance role name string, so if there is no role name, we'll simply return a blank, like an empty string. Okay, now to normalize, let's say normalized, I'll use role name dot lower dot strip. Okay, and this lower function will help us to convert every word into lowercase, and this dot strip function will help us to kind of cut out all those extra white spaces for every words or every letter. Okay, all right, so after converting into lowercase, we need to make sure that we don't, like, we have to make sure that there is no more any punctuation problem. So again in normalized, and here I'll be using my regular expression, so regular expression subtract regular expression string with this my exponential sign /w/s. all right, and here or any blank spaces, so and then normalized. Okay, and what we did over here, that this particular regular expression function will kind of help us to remove any non non-alphanumeric characters, like thing like punctuation that I have said earlier. So, and to give you some example what it means, let's say I have this, not here, right? So let's say I have senior developer, right? I need to convert that into this senior developer, so I can't allow this kind of dot in my comparison time in my words. Okay, so that's why I need to subtract them from my words using this relational, like this regular expression function. Okay, after that we have our fuzzy match. Here we'll be comparing the fuzzy logic matching. Okay, so first we need to pass our both the string, so string1 string, string2 would be also string, and we need to pass the threshold. Threshold which will be in the form of int, and this function will be giving us the value with in the form of bool. Okay, so what will return, will simply return our fuzz dot ratio of string1 of string2 with, and we need to compare this with my threshold. I hope you remember that in our config file we have set the threshold as per 80. So this function will compare my two roles, from one from PDF and one from XML, and it will match it string by string, and if the comparison ratio value got above more than our threshold, it will be mentioned as a similar role, and if it goes below the threshold, it will be considered as a like not similar role, like simple. Okay, all right, so now for the chunk test function, right, and it will help us to break down our document into multiple chunks. Okay, so first let me just pass couple of parameters to it. One would be the text, mean that whole document, then our chunk size, which will be in case in a form of integer, which will be 1000 of course, then overlap integer, and it will give us in the return in the form of list. Okay, all right, now why I'm using this chunk size, this chunk size kind of signifies that in like how long each piece of this broken text should be. Okay, and we'll be having 1000 of characters each that I have mentioned in my config. Okay, and this overlap and this overlap parameters kind of signifies a crucial that a very crucial thing, that imagine a crucial sentence is split exactly in half by a chunk boundary. Okay, now overlapping ensures that that particular sentence appears fully in at least one of the chunk, preserving the context of that particular sentence meaning. Okay, so first we'll start by initializing an empty list where we'll store our chunks, then start our start index with 0. Then we need to run a loop to create those segments. Okay, so I'll run a loop from start, and we'll run this loop after this start would be less than the length of my text. Okay, and then I also need to define the end of my text, so minimum of the start of the text plus the chunk size that we have with the length of my total text. Okay, and this will give me the end of our text, right? Then we simply need to append our chunk, so chunks append, and we need to get our segment, right? So here we are kind of iterating through our text, right? Now at the time of iterating, we have to ensure that the text is ASCII compatible, which can sometimes prevent issues with our embedding models or some specific databases, right? So I'll just simply paste this command. You could see here we are getting our segment of text from start to end with encoding our ASCII with ignore dot decode our ASCII. Okay, after getting this segment, we'll simply append this into my chunk. So chunk dot as I mentioned as chunks, so chunks dot append. Right, and what I'll append my segment. After that, if my start class chunk size is greater than the length of the text, what I'll do, I'll simply break the loop. I'll simply break it. Then start plus chunk size minus overlap, and this block will help us to avoid that infinite loop if chunk size minus overlap is 0 or less. Okay, so so let's imagine that we are chunking, but we have reached the end of our document, so we don't need to chunk the document again, right? So there we need to break the whole loop. Okay, then I'll simply return my chunks, which is in the form of list. Okay, done. Now we need to create our PDF extractor and our XML parser file. All right, so now we need to create those modules for our extracting the text from our documents. So we'll be having two kind of documents. One is our XML file and one is our PDF. So so for the XML part, so we'll be creating a file. Let's say XML parser xmlparser.py. all right, and to parse any XML file, one of the most powerful and fast library in Python is lxml.etree. so I'll import that. So from lxml, I'll simply import my etree and I'll import os, and this would be kind of to help us to check if our XML file actually exists or not. Okay, now we need to create the function. So extract role from XML. Okay, and this function will take a couple of arguments, right? So first argument would be our XML file path. So XML file path, which would be in the form of string, and also the role path. And this role path significance that how our this parser will query through our XML to extract those roles. So let's say role path, which should be string. Okay, and this function will return a list of extracted string. Okay, all right. So the thing I said about this role path, which is a pretty important XPath expression, which is a kind of a query language for our XML files. It tells our parser exactly like where to find the role names within this XML structure. Okay, so after passing those arguments, let us first check that do we even have the file or not. Okay, so let's say if not os dot path exists of this XML file path. So if there is no XML file, we'll simply print an error statement as error in finding XML file. Okay, and for a safety check, we'll be returning a blank list or an empty list. Okay, all right. So after that, of course, we'll be using a try except block, try, and we'll be using our except. So except for to handle our XML parsing exception, we'll be using etree dot XML, which XML syntax error as e, and we'll print simple error. Let's say error parsing XML file. Okay, pass the value and we'll simply return an empty list. Okay, and again another exception. This is to handle or simple any unexpected error while parsing this XML file. Okay, so I'll just copy this two line and I'll paste it over here. Okay, so it will be unexpected error, unexpected during parsing XML file. All right, now in this try block, we need to create the we need to create the function for our parsing, right? So we'll be using e3. So e3 dot, let's say our XML parser. So XML parser here. Okay, so this function will help us to kind of parse our XML file, and this function needs some arguments. So those are this recover true, and for the encoding format we'll be using encoding of UTF-8. Okay, and we'll be taking this parser into a variable as parser. All right, and this recover true argument or parameter, this kind of a handy feature that tries to fix those minor XML errors. Okay, and this encoding UTF-8 ensures that we handle common text encodings. Okay, so after that in tree we'll take our parts. So a tree parts, here we'll pass our file path and the parser will be our parser. All right, so this kind of reads and parses our XML file into a tree structure. After that we need to extract those lines. So for that, in my, let's see, my roles variable here, I need to run a loop through my those parse elements. Okay, so let's say for element in my tree dot this x path, so x path, and here I need to provide my role path. So role path if element is not none. Okay, so when there is an element and we'll loop through our role path, so we'll simply extract our string of element. Okay, and we'll use this type function. Okay, so here you could see that when this role x path includes this function, and all right, so here in this tree dot x path, and this is where we have our x path. Okay, it takes our role x path and traverses the whole XML tree, finding all elements or takes node that match that path. Okay, then we iterate through each result found by x path, and we ensure that only process valid elements, and this is a pretty much a crucial details. Alright, so now we need to extract those roles from this parse tree, right? So in my roles variable, I'll run a loop through my those parts elements. So for that let's say for element in my tree dot, here I'll use my x path where I need to provide my role path that I have talked earlier. Okay, and we'll be doing that if there is an element. So if element is not null. Okay, so if there is an XML and like if there is an XML parse tree, then we simply need to extract that. And how will we extract? We'll use the string, we'll pass our element, not element, it will be element, and as there could be any kind of white spaces, so we'll be using our stripe function. to eliminate those white spaces. Okay. All right. So after that, we simply need to return these rows. We'll be returning these rows, and that's it. And this function will help us to extract our XML files. All right. So we have built our foundational tools like our Gemini client, Pinecone client, our XML parser, and our utilities for our helpful functions like chunking and all. Okay. Now it's time to bring it all together in our PDF extractor rag.py file. Okay, and this is a module that handles all the heavy lifting of processing our PDF documents and answering questions about them. All right, so first I'll create a file as PDF, let's say PDF extractor rag.py. Right, now first let's start by getting our imports in place. Okay, so we import our fetch from PyMu PDF for our PDF manipulation, chunk text from our utils, and our GeminiClient and PineconeClient, and some configuration constraints. All right, and we also kind of grabbed our UUID for generating unique IDs and not found exception for specific Pinecone error handling. All right, so we have around 6 imports over here. Okay, now we need to kind of set up our basic class structure. Okay, so for that I'll define a class name with, let's say, RAG PDF extractor. Okay, now I need to initialize this class. So for that, def init, I'll pass self. Right, and here we'll simply create some instance for our Gemini client and our Pinecone client. Right, so self dot our Gemini client, so client should be our Gemini client, and self dot Pinecone client. For this we have our Pinecone client. All right, now we need to define 4 to 5 important functions that this particular class will perform. Okay, so now is the time for our first crucial private method. Okay, which is our extract. The name would be extract text table from PDF. Right, and here we need to first pass our self parameter and our PDF path. Okay, so PDF path, which will be in the form of string, so string, and this whole function will be returning value in the form of string, so str. All right, so now we need to initialize an empty list where we'll be storing our extracted text. So text an empty list, then simple try except block, try except simple exception as e. Okay, and here we'll simply print that error during extracting. Okay, good, then simply return an empty string. All right, now in this try block we first need to open our document. Right, so for that, let's say the first thing we'll be doing, we need to open our document, so PDF document, and to open it we'll be using fetch from our PyMu PDF. So fetch dot will use this open function. Open, here I'll pass my PDF path which I want to open. Okay, all right, so after that I need to kind of iterate through my whole PDF documents. Right, so for, let's say, a simple variable name page number in the range of my PDF, it's not PDF path, my PDF document dot page count. Okay, so how many pages of your PDF we have we need to iterate through them. Okay, then we'll be loading each and every page. Okay, so for that, in my page variable I'll be using this PDF document dot load. All right, so not PDF path, PDF document dot this load page function. Here I'll simply pass that page now. All right, okay, now after loading one page, let's say we have loaded the first page. Now we need to extract the text blocks, right? So for that, text blocks, I'll use my page page dot get text. So get text, okay, and here I'll simply pass my blocks. All right, so after that I need to I need to iterate through my each and every block. So again, a loop for block in my text block. So in my text blocks, here I'll simply need to append my each and every block to my this full text list. Okay, so full text dot append. I'll use my block of 4th of index, and I'll simply use this type function to kind of extract any white spaces. Okay, and why I'm doing this block 4, because this 4th index kind of consists our text content. Okay, after that we need to extract our tables, right? So for that, let's create a variable of tables. Here I'll use page dot find tables. So find tables function, and here I'll be using this function. So after that, again after getting a table, I need to iterate through the table. So table in tables, I'll create a table rows to append my all table rows. So table rows and empty list, and then again I'll be kind of iterating through this particular table. So for the particular row data in this table dot extract, so extract. Okay, so for row data in table dot extract, I need to append those row data into my this table rows empty list. Okay, so simple table rows dot append. Now to kind of showcase the table in my GUI or in the application, we need to use, I'll be using this pipe delimiter. Okay, so this, then I'll be using this join keyword. Here I need to use a for loop to extract those row data cell by cell. Okay, so let's say after join here, say if cell is not none, mean if each and every cell we have some value, so we'll be having our cell. Okay, cell is none, else will be iterate. So for cell in my row data, right, my row data, and then wait, so this this block is finishing over here, and This indentation is finishing over here, this one is finishing over here. So table dot append join save is not none. Alright, so this would be is. Okay, now after that, in my table string, we'll use this dot. So in my next line, I join the next table rows. So my table rows. Okay. All right. Then after done all these things, we need to simply, let's say, under this indentation. So here we'll be closing our PDF document. So PDF document dot close. Okay. All right. So this one is, so our extracting text and table is done. Then simply we'll come over here, and in my full document text, a new variable where I'll simply join my whole text and my whole my extracted PDF. Okay, so /n, then simply join the whole full text. Okay, then simply return full document text. Alright, so now that we have created the function for extracting text and table, now we need to make sure that we have upserting this text into our vector database. Okay, so for that we're creating a function as process the PDF. Okay, now here again pass the self. We need to pass our PDF path, which is in the form of string, and then our PDF ID, again in the form of string. All right. Okay, now first we need to get our text. So text would be self dot, let's call our function, right? So we have this extract text table from PDF function. We'll call this, we'll simply pass our PDF path over here. All right, now again for a safety check, if not text dot strip, mean if there is no text we have gotten, then we'll simply print, or we'll simply show, or we'll simply return a empty string. Okay, so no content extracted, right? Then simply return the function. All right, now imagine we have the text. Now the first thing we need to do with that we need to break that text into chunks, right? So our chunks, now of course we need to call our chunk text function, chunk text. Now pass our text, then we need to pass our PDF chunk size. Okay, also we need to pass our PDF chunk overlap, and we have imported these constants over here, you could see. Okay, so we are passing this parameter in our chunk text, and after that we need to create an empty vector to upsert variable, or empty list of vector to upsert. Now we'll be needing now we need to upsert our vectors, right? So we have these lots of chunk, so we need to iterate through our chunk first. So for I and the chunk, enumerate my chunks, then the first thing we need to do, that we can't just upload my raw text, I have to upload those embedding vectors, right? So simple embedding here, I'll call myself dot my GeminiClient, which has a particular feature as embed text. I think now everything is making sense. Okay, chunk. All right, after that, if we have an embedding, Now if we have an embedding, we use our we need to have a vector ID, and here I need my PDF ID, and with uuid dot uuid4 of dot with the format of hex. Okay, and the reason I'm doing that, because in our Pinecone vector database, each and every vectors should get represented with a unique ID. So that's why I'm using this UUID library to kind of generate those unique ID for each and every vector. Then of my vectors to observe, simple dot append. Here I'll pass my vector ID and my embedding and my PDF ID with my PDF ID, let's say this, and then I need to pass my chunk index. So chunk index, which would be my I, and the content. And here this content would be my chunk. Okay, all right. So after that, we'll come over here outside of this for loop. Okay, with this for loop, then if I have some vector to observe, then I'll simply use a feature which is under my PineconeClient. So I'll call my PineconeClient, and from my PineconeClient I use my observed vectors, and I simply pass with the parameters of vectors to observe. Okay, all right, then simply print a statement so that we get to know that what's happening. So processed and indexed chunks. All right, and if and else we do not have any embedding to observe, we simply showcase text that there is some problem. So we'll simply write no embeddings to process and index. Okay, have extracted data from our PDF, we have processed them, and we have uploaded them into our Pinecone vector database. Now we need to extract those roles from our PDF, and we need to get a simple list of that how many roles do we have in my PDF, right? So for that, let us create another function. I'll just minimize this function over here. Okay, and this. Now let us create another function as def extract the roles from my PDF. Okay, with passing myself and my PDF path into it. Okay, and I'll be getting the response in the form of list. So list. All right. So first we need to extract, right? So extracted text, here I'll call myself dot extract text table from PDF function. I'll simply pass my PDF path. Okay, then if not extracted text, then simply return a empty list. Okay, you can print any statement that there is some issue, but I'm just simply returning a blank empty list. All right, now to extract those rows from PDF, we need to use our prompt. Okay, so let's say I'll be write a prompt. So prompt over here, then my f string, I'll call my role extraction prompt, okay, then some new line, then document content, and this is to showcase that what is my document's content is. Then again new line, and I'll be showing my extracted text over here. Okay, all right. Now we need to get those raw roles that I've said earlier. So raw roles string, here I'll call myself.GeminiClient with generate text, and I'll simply pass my prompt over here. All right, now to showcase the prompt, I'll be initializing our empty list. Here I'll iterate through this. So if raw roles string and raw roles string dot lower means the whole one, and after converting everything into a lowercase, if there is nothing, then none would be in the quotation. So if there is nothing, then we should return a set of roles. So for that, my roles I'll simply use, and simply to iterate through this. So for role in my raw roles underscore str. All right, here simply I need to split it with the form of a dot, and if role dot strip. All right, and to showcase the value, I'll call role dot strip. Okay, so after that I'll return the list. So with the list, I'll return over here my set of rows. Okay, all right. So for an safety check, elif my raw rows lower is none, mean we have no element. So we'll simply, let's say, print Gemini reported no rows. Okay, simple. Then again for the else part, again Gemini returned empty list, and simply return an empty list. Right, so sometimes especially during the testing, you will want to kind of clear out your data associated with a specific PDF. Okay, so that's where we'll add this function. It's not necessary, but it's useful when you use this kind of function. All right, so what I'll do, I'll simply let me first minimize these functions. Okay, so I minimize that, I'll minimize that. Okay, and I'll have this function over here. Okay, so here you could see we have this clear PDF data function, and this method directly interact with the Pinecone, and it tells it to delete the vectors. Okay, and you could see the key over here, this filters of PDF ID of $EQ, and this is the key over here is the this one. So this ensured that we only delete the vectors that belongs to a specific PDF document ID, rather than the whole entire index. Okay, and it's useful when you are building this kind of application to kind of use this kind of function for your testing purpose. Okay, you might use it or you might not. Okay, as of now we have done our extract text tables from PDF, process PDF, extract rows from PDF, and clear PDF function for this RAG PDF Extractor class. Now the last function that you need to create is for that query our Pinecone vector database, and this query would be for any general query or any query about the table. Okay, so def query, let's say Pinecone. Okay, I'll pass myself parameter over here and PDF path, which is string, and the query that user will be giving, which will be in the form of string. Okay, then it will be in the form of string. This, okay, right. Yes. All right. All right. So the first thing we need, that after having the query, we need to embed that query. So in my query embedding here, I'll simply call my GeminiClient, which has an feature as embed text, where I'll simply pass my query. Okay, now let's say if not query embedding, I'll simply return no embedding. Okay, all right. So after having this query embedding thing, we need to search through our query vectors, right? So in my results, what I'll do, I'll call my PineconeClient now, PineconeClient, and I'll use my query vectors, and I'll simply pass my query embedding and the number of chunk I want to get, so 10. So as per this query embedding, how many relevant query vectors I can get from my vector database, and that I'll store in my result. Okay, again for some safety check, that if not results dot matches, will simply return no relevant chunk. Okay, so now we got our query, we got our embedded query, we have passed that to our vector database, and we see, okay, we have couple of relevant chunk. Now we need to get the context, okay, which I'll be providing through my LLM, right? So for that, my retrieved context I initialize an empty list. Okay, and I'll be retrieving this context with the help of the metadata. Okay, so for match in results dot matches, if the metadata in the match and the content is in this my match dot metadata, okay, then I'll simply use this append to add it into my retrieved context list. Okay, so match dot metadata with the content. All right, okay, then with else, let's say no metadata. All right, now again I'll just copy this, one, and I'll paste it over here. Okay, and in the place of this query embedding, I'll use, if there is no retrieved context, sorry for the indentation. All right, so if there is no retrieved context, I'll simply write text that no context. Okay, but if there is a context, I need to get that in a particular variable. So let's say in full context, I tend to join them, so that with I'll simply join here, I'll pass my retrieved context. Okay, now I need to pass this retrieved context to my LLM so that I get a good precise response. Okay, so now we might need to tailor our prompt a bit. Okay, so for that I have already tailored the prompt for the table data extraction. All right, and this is small but effective piece of prompt engineering. If the user asks about tables or count, we tell Gemini to specifically focus on the structured data in its answer. Okay, and this will kind of helps to guide the LLM to give more accurate answers when dealing with some numerical or some tabular information. All right, so after that I'll come over here, and here I need to get my answer. So in answer I'll call myself GeminiClient with generate text, where I need to pass the prompt. Okay, and then I need to simply return my answer. Okay, so my this PDF RAG extractor file is done. It has this class of RAG PDF extractor, which with these 5 features. Okay, now we need to create the file for our role comparer, where we'll be using these little functions to compare the roles between our XML data and our PDF data. Alright, so we have done our document processing part, where we have done XML parser and our PDF extractor. Now we need to create the main important file, which is the role comparison file, or the role comparison module, that will help us to check that the how many roles are similar with our XML and our PDF. So before that, let me show you our PDF file and our XML file. Okay, so for that I'll create a folder over here as data. So data, and here I'll create 2 more folder. One is XML path, all right, and another one would be as PDF path. Okay, and now we need to get our files over here. Okay, here you could see we have this document with roles PDF that contains this PDF with company staffing overview, and it's mainly contains with all kind of possible kind of roles that an organization might have. Okay, we have this project managers, software engineers, senior developers, we have QA testers, we have data scientists. Then we have this table where we have a couple of important roles as software engineer, senior developer, business analyst, marketing lead, product manager with their count, and some other as operations specialist, all those things. Now we have this master list, our XML, which we have to compare. Here we have the software engineer, project manager, senior developer, QA tester, business analyst, and data scientist. So our work would be, as I said earlier, that how many roles that this comparison should be similar for this 6 this 6 roles should be in this 6 PDF, or this 10 to 11 rows should be in this XML file, and if there is any changes, that particular file should be considered as an incorrect file. Okay, so this is how it's done, and now let's create the logic for our role comparison. Alright, so now the final logical step would be to compare the roles we have found in our PDF against our XML files. Okay, and that's why we'll be creating our role comparer module. So let me create a file. So role comparer.py. Alright, so let's start by importing our elements, our libraries. So from typing, I'll import list, and I'll import tuple. Okay, and this will help us to for our type hinting, which will make our code clearer. Okay, and then we need to bring in our normalized role and our fuzzy match function from our utils module, and this will be the these are the main function of this module, because we need to compare our roles, right? And we also need to get our fuzzy match threshold from config.py. So from src.utils, as I said, I need to import my normalized role and fuzzy match. Okay, then from config, so from config.config, I need to import fuzzy match threshold. Okay, now let us create the class. So class role comparer. So comparer, simply initialize our init method. So init passing our self, and we need to pass our fuzzy threshold. So fuzzy, I think the spelling is not wrong, it will be fuzzy threshold, which would be this fuzzy match threshold. Okay, then I simply need to store that. So self dot fuzzy threshold would be my fuzzy threshold, not match threshold. Okay, and now for the main logic, we need to create our compare rows function. So here we'll create compare rows function. Okay, so now for this compare rows function, and this function takes three arguments. One is the self, so it's self parameter. Then it takes our XML rows in the form of list of string, and it takes our PDF roles, so PDF roles in form of string. Okay, and it returns the value as a tuple. Okay, and this tuple returns us first the value of bool, and this bool consists that matching of these rows of XML file and PDF files are correct or not. So it will be either correct or incorrect, and then it will provide us the matched roles. So for that, again, I'll be using list of string, and again a list of string. So this first list of string is that matched roles, and the second one is that incorrect matched roles. Okay, so list of string. Okay, it won't be first bracket, it will be a third bracket. All right. All right, so now the first thing we need to do that first we need to normalize both set of roles, right? So we convert XML roles into a set of normalized strings using our normalized role function, right? So for that, I'll get a variable as normalized XML roles. Here I'll call, like let's say I'll run a for loop. So my for role in all my XML roles, what I'll do, I'll simply call my that normalize role function. So normalize role, where I'll simply pass my role. Okay, done. So I have converted the roles into those normalized way. Now I need to do the same with my PDF roles, but we also need to create some normalized PDF to original part, which is a, like, we need to create a dictionary to kind of map our normalized version, like our normalized version of our PDF role back to its original string, right? So let me show you what I'm trying to say. Let me get a comment first. So let's say create, we need to create a mapping. So create a mapping from normalized PDF roles to its original string. Now how would we do that? It's a normalized PDF to original, right? Now here in the second bracket, again for role in PDF roles, what we need to have over here, we need to have our normalized roles, pass our role, and simply with our role. Okay, we need to map it with our role. Alright, then again normalized PDF roles would be the set of my normalized PDF to original roles with the keys of the maps. Okay, so the role that I have mapped with this normalized role, I'll be using that keys function to get that. Okay, all right, so after that I need to find the direct matching. Okay, and to do that, what I'll do, I'll use this my normalized XML roles. So normalize XML roles and use intersection method, where I'll simply pass my normalized PDF roles. Okay, and the value I'll store them in my matched normalized roles. Now this signifies that, let's say I have 4 roles in my XML, let's say A, B, C, D, and in my PDF I have 6 A, B, C, D, E, F. So in this variable I'll be having A, B, C, D, which are the both the common roles in both in XML and PDF files. Okay. Alright, so after that I need to kind of I need to identify the roles in my PDF that are not exact matches in XML. So in our previous variable we have taken the roles that have matches in both the files, but now we need to take the roles that are the uncommon in the files, right? So for that, what I'll use, potentially, because there is a potential of everything, because we'll be using fuzzy logic, so there is a chance for some error. So potentially incorrect PDF normalized. Okay, I'm kind of keeping these variables names longs to kind of understand the meaning easily. Okay, so now my normalized PDF roles, from that I'll subtract my normalized XML roles. Okay, and I'll simply get those roles that are not common in my PDFs, but we have in XML, right? All right, so after that we need to use our fuzzy matching for every role that didn't have a direct match. Okay, so let me give a comment again. So we'll be trying fuzzy, so try fuzzy matching for potentially incorrect PDF roles. Okay, so let us do that. First we need to create an empty set. So still incorrect PDF normalized. Okay, an empty set with this, still incorrect PDF normalized. All right, okay, so now we need to run a loop through our this set. So let's say PDF norm in my this, still put not static one, this in this potentially incorrect PDF normalized files. Okay, now here I need to first get my original PDF role. So my original PDF role, which is simply I'll be using this normalize PDF to original and PDF norm. Okay, now let me just initialize a variable as found fuzzy match as false. So whenever we will be seeing any particular match, we will be converting this flag as true. Okay, so after that, let's say for XML norm or XML origin, so XML orig in my all XML roles, I'll be iterating through my XML roles, and if the particular fuzzy match of this original PDF role and my XML sorry, it will be XML original, so orig, I need to change this as well, so orig. Okay, so if the fuzzy match between my original PDF role, my XML origin, and my self dot fuzzy threshold, then as I said earlier, I'll be converting this flag into true. Okay, this is not XX, this is ZZ, right? So okay, so we are using this true and false to flag our comparison. Okay, so now again, let's say if fuzzy match found, we need to consider it correct, as that is our main agenda, right? So what we'll do, in our match normalized roles, I'll simply need to add them. So add, I'll use my normalized role where I'll pass those particular XML orig roles. Okay, and after having that, I'll break the loop, and again break the loop, and I'll come over here, and if there is not found any particular found fuzzy match, so if not found fuzzy match, then this still incorrect PDF normalized from would be this PDF norm. Okay, all right, so after that, when we need to just determine our is incorrect variable, okay, which is true or not false, all those kind of things. So my is incorrect variable, I'll use the bool to get the final outcome, is it yes or no. Okay, then I need to convert the matched roles to their original XML strings, right? So to do that, what I'll do, again a variable as final matched XML roles. Here I'll simply again I'll use a for loop with XML origin in XML roles. Okay, and I'll be taking that XML origin for XML origin in XML roles if those normalized function, those normalized XML roles reach in my match normalized rules. Okay, match normalized rule. All right, now after converting this to a normal XML string, we need to convert incorrect PDF rows back to their original PDF string. So to do that, again convert PDF rows back to original PDF string. Now we'll do that again with this final incorrect PDF rows and again we'll be using a simple for loop. So for my role norm in my still incorrect, so for role norm in, let's say, wait a minute. So for norm roles in my still incorrect PDF normalized, so I'll just copy this from here, I'll paste it, normalized. What I'll do, I need to simply take my normalized PDF to original, and I'll simply need to provide my roles form. Alright, now as I said earlier, we need to return a tuple, which would be this is incorrect, like that bool, and that sorted list of our final incorrect or our final matched XML rows, and again a sorted list of set of our final incorrect PDF rows. That's it. Right. So after having our this compare rows function, we need to have a value. We need to make our validation clear and actionable format. Right. So for that we need to create a generate report function that will give us a proper output of this whole comparison operation with a proper structure output. Okay, so for that I'll have this function that I'll be just explaining you over here. Okay, so this method, this generate report method, simply takes the result from our this compare roles, and it prints them out in a human readable format to our console. Okay, and it provides us the counts of unique roles in both this our XML and PDF. It also provides us the list of list of all the rows that were successfully matched, and most importantly, if is incorrect is true, it clearly lists the incorrect PDF roles, that these are the rows that didn't match anything in our master XML list, right? And finally a clear conclusion indicating whether the PDF roles are ultimately correct or incorrect. Okay, so this report is pretty crucial for a user to quickly understand the validation outcome. Alright, so now having this done, we need to create our main.py file that will help us to run this whole application properly, and we'll be having our outcome in our terminal. Okay, right, so as of now we have built all the individual components for our XML role validator. We have built XML Parser, our GeminiClient, PineconeClient, our PDF extractor, our some utility functions, and the role comparer. Now it's time to bring it all together in this main.py file. Okay, so I need to create this main.py. So main.py. Okay, so let's start by seeing the imports for this file. Okay, so here you could see, so we are simply pulling all the key classes and functions that we have built. You could see we are pulling our extract rows from XML from our source.xml parser, RAG PDF extractor class, role comparer class, and the reason I was using that object-oriented programming architecture is because of that, so that it will be easy for me to also handle all those small modules. Okay, so we are kind of just pulling this class from RAG PDF extractor class, role comparer class. Okay, and also we are kind of importing couple of these constraints and our OS for our path management, and UUID over here for our creating our unique IDs and Pinecone specific imports for a special cleanup sets, for a special cleanup step. Okay. Alright, so after that we need to define the main function, right? So over here we first need to configure our file path. So configure file path, right? Now the first configure would be path to our XML roles, right? Now to get that, I'll declare a variable as XML file path, and I'll use os dot path dot join. I'll simply provide as the data I want to take and my XML data, okay, and my defined roles.xml, which would be the name of my XML files over here, okay? And you can make it dynamic if you want. There will be just some modification of some code, okay? So after that, our path to our PDF roles, right? So here I'll use PDF file path, again os.path.join, and the reason I'm using os.path.join because it will help you to use this application in a like as a platform independent way, okay? Again we'll be using data, then our PDF data, and the name, let's say document with roles.pdf, and you could see these are the name of our files, our defined roles.xml and document with roles.pdf, okay? It would be under quotation, so under single quotation. All right, okay. And after that I need to make sure of the XPath to extract role text from XML, okay? And what this means to say that in my defined roles.xml you could see we have the format in this way, right? So let me just copy this from here to here. Let's just keep it over here, and we have another role like this, right? Okay, so for this our XPath would be like that, slash slash, as we have two roles first, so slash slash, then we have to mention our role, okay, then again slash and text function. All right, so this is the common example of how to adjust your XML path. Let me give you another example to show. So let's say we have employee, then we have this employee, and in the middle let's say I have my text. So for this my XML path would be slash slash, as I am having employee, again a slash text function, okay? But now if I just use another one over here, let's say a title, and also title, for this I simply need to add another slash and title, okay? So this is how you can define your XML file path, and this will kind of help to extract the roles, extract the main text from your XML files, okay? So in our case we need to extract them, so XML role path, so slash slash role slash text, okay? Now we need to set up our directories, as we have our PDF path and XML path directories, right? So set up directories, Okay, and we'll be using os dot make dirs. Here we'll use os dot path dot our directory name. We'll pass our XML file path, and here exist, okay, true. And this means that if our this particular file path exists, then we do not need to create that particular folder. But if that particular folder doesn't exist, this os.makedir will create that particular directory for us. Okay, and these are always okay for some safety check. So I'll again paste it over here, and I'll just change its name to PDF file path. PDF file path. Okay, so now for our convenience, and especially during the initial setup or testing stage, we need to include a way to create a dummy XML file process. Okay, so for that we have this particular block of code, and what this block does, this block checks for and creates a sample of our defined roles.xml. Okay, so if by some case if our defined roles.xml is missing or overwrites it, okay, so we can easily change this dummy XML content so as per your wish. Right, so yeah, so here we have software engineer, project manager, senior developer, QA tester, business analyst, and data scientist. Okay, and it will only be comes under the work while we don't have any XML file under my XML path. So now this next part is really important. Okay, so here we explicitly check if our PDF path, which is our document with roles.pdf, exists or not. Okay, so if it is not, the script particularly provides a detailed instruction on how to create a simple PDF with some sample content and where to place it. You could see we have PDF file not found at the PDF path. Then and only it will give us some instruction that please create the PDF document using Google Docs and export, then with sample job roles and save it as os.path.basement file path in the os.path.dir name directory. Example content for your PDF, we are kind of suggesting some example content with the form of table of staffing, role, count, project management, data science, then exit. Okay, now we must manually create this PDF for the script to run. Okay, and the reason I'm doing this because to make the first time setup as smooth as possible for anyone using our project, right? Because not everyone should know that what's the input should be. So even if someone forget to add any PDF file or XML file, this particular two blog, this create dummy XML file and this helping to prepare your PDF file will help them to create those files and give them as their input. So before we start processing, there is an optional but highly recommended cleanup step for the Pinecone part. Okay, so I'll be just pasting the code over here, and what this particular block of code does, let me just show you. As you could see in the comment that it says clean Pinecone index for a fresh start, especially for the free tier. Okay, and the reason is that, see, this block uses the direct Pinecone client. You could see our Pinecone client over here, this particular word Pinecone client, to check if an index with our specified name already exists or not. So if Pinecone index name, which is our index name, exists in our Pinecone index, okay, then we simply delete this index. You could see pcdo.delete the index, and this is kind of incredibly useful for the free tier, which often has some strict limits on the number of indexes or vectors. Okay, and deleting and recreating ensures we always start fresh. We also add a time limit of time.sleep 5 or 5 seconds to give Pinecone a moment to fully process the deletion before our Pinecone client tries to recreate it. Okay, and if there is any API error, our Pinecone API exception handles it, and if there is any other error, we have our exception to keep the so kind of keep our application momentum running. Okay, now after that we'll be creating the our total applications workflow step by step. Okay, right, so now let's run through the code step of our validation process. Right, so the first step is, let me comment it as extract roles from XML. Right, so let me print something as extracting roles from XML. Okay, and to do that, simply under this variable XML roles, I'll call my extract roles from XML function. I'll simply pass my XML file path and with my XML role path to show that how you can extract roles. All right, again a simple print statement to show what's happening. So extracted roles. Okay, then a safety check, if not XML roles, will simply print that no roles extracted. Okay, all right, so after that our second stage would be initialize RAG PDF extractor. Right, so let me again the print statement RAG PDF RAG extractor. Then to do that, simply PDF extractor. I'll call my that RAG PDF extractor client. Okay, all right, so now the initialization is done. Now after that, the process the PDF and extract roles. Right, now to do that, for our every PDF we should have our unique ID. Right, so PDF ID, let me give a unique ID. So document ID 001. Okay, all right, then let me print a statement as clearing previous data. So even if we had some previous PDF data, we need to clear this thing out. So PDF extractor dot clear PDF data, I'll pass my PDF ID. Okay, so now my ID is properly fresh. Now again a statement to show processing PDF for indexing in the next stage. For indexing in the next stage, right? And how we'll do that? We'll do that simply using our PDF extractor with the function our process PDF that we have built, and we'll simply pass the parameter of our PDF file path we have over here and our PDF ID, like which ID we want to do that. So PDF ID, PDF ID, right? Okay, so now in our next stage, after processing the PDF for RAGs, we separately call our PDF extractor dot extractor rows from PDF. Right, so let me just print. Wait, so if I print a statement as say extracting roles from PDF. Okay, and how will we do that? Simply our PDF roles, and we'll use our PDF extractor dot our extract roles from PDF function. We'll simply pass our PDF file path. You see how easy for us to bring it all the modules together. Then again, extracted PDF roles. Okay, again for our safety check, I'll just copy this one, I'll paste it over here, but it would be PDF roles. So PDF roles, no roles extracted. Okay, now after extracting our XML roles and our PDF roles, we need to compare. So compare rows, and this would be number 4. So 4. Okay, again let's say comparing roles. And how will we do that? Let's a simple variable as comparer. Here we'll call our role comparer class, where we'll pass our fuzzy threshold, which would be this fuzzy match threshold. Okay, and then our is incorrect, comma our matched roles and incorrect PDF roles. Here we need to get those values. So comparer dot, I'll call that compare function compare roles, where I'll simply pass my XML roles and our PDF roles over here. All right, so this is how we'll get our that comparison is correct or not, and we'll get our matched rows and our incorrect matched rows, not incorrect. So incorrect matched rows. All right, so after doing the matching, we need to generate the report, right? So generate report, and to do that, again let's say print generating report, and again we'll use our comparer dot our function generate report function. We'll pass our is incorrect, we'll pass our match roles, simply matched roles, and our incorrect roles. Why is that? Our incorrect PDF roles. And also we need to pass our XML roles and our PDF roles. All right, okay, and at last we'll simply print that end of process. Okay, and now to initialize this whole main function, we need to ensure that main function is called only when the script is executed directly, right? So for that I'll use our famous method. Need to initialize our main. Okay, here I'll call my main function. Okay, we'll simply save this. So I have done 2 slight changes. I have changed the name from PDF path to PDF data and XML path to XML data, and that was in our main.py directory file, right? Okay, so now it's time to build our Streamlit app.py that will help us for a clear UI. Okay, so we'll start with import our libraries. So we'll import, okay, import Streamlit as ht and import OS, and we need to import OS, and we need to import temp file to store those temporary files that user will be uploading through our PDF uploader and XML uploader. And then from .env we need to import load.env. Alright, so now we need to load our .nb function. All right, then we need to import our couple of core logic from our source folders modules, right? So from source.xml parser we need to import our extract roles from XML. Then from source.pdf extractor RAG we need to import RAG extractor, and from src.role comparer we need to import our role comparer. Okay, then from config we need to import fuzzy match threshold, our Pinecone API key, and our Pinecone index name. Okay, then from Pinecone we need to import Pinecone. Then for the relaxation time for our index creation we need to import time. All right, now we need to create a function as, let's say, run comparison. Okay, here we'll simply pass our XML file, so XML file and our PDF file, I'll pass them. All right, so now here the first thing we need to do, that we need to create temporary files for processing, right? So here what we'll do, to use this temp file option, we'll use with temp file, I'll use this as named temporary file. Here I'll use my delete the false, I don't want to delete it. Then the which kind of file I want to upload, for this one let's say .xml, so XML. Okay, and I want to store it as my tmp XML. Okay, now in my tmp XML dot, I need to write the file, so write, I'll simply pass my XML file dot get value, so get value, right? So XML file dot get value after tmp XML dot write. Now XML file path would be this particular tmp, my tmp XML, so tmp XML dot name. Okay, so right now my file is stored in this XML file path. Okay, now for the PDF I'll just copy this code and I'll just paste it over here, right? So here what I'll do, I'll change this XML name to PDF, and this would be PDF, so PDF, and here I'll change it to PDF, and again this would be PDF file, and again PDF, and just changing this name to PDF. All right, so now for the Streamlit UI, let me first create a try except block. So try, under it I'll use, so first let me just use the exception as he. Okay, then I'll simply print ht dot error, and here I'll simply use, let's say, an unexpected error occurred. Okay, now here just I'll use subheader, use, let's say, process started. All right. Okay. And after this, just to show the exception, ht dot exception, I need to pass the parameter. All right. And after that, I need to use that keyword finally. And here, I simply need to clean up my temporary files. Okay. So os dot path dot exists. Here I'll pass my XML file path, and I'll use os dot remove my XML file path. Okay. Same for os dot path exist for my PDF file path, and if it does exist, then I'll simply need to os dot remove PDF file path. Alright, now let us create the UI, and then after creating the Streamlit interface, then we'll create the main backend logic here. Okay, so again st dot set page config, right? In the page title, I'll give role validator application. Okay, layout, I'm just keeping it centered. Then st dot title, here I'll use role validator application, or you can say XML or validator application. Okay, then st dot markdown, and here I'll write upload your XML and PDF file roles to validate. Done. All right, so now I need to create my file uploader. So file uploader, here what I'll do, in my uploaded XML file variable, I'll store my XML files. So ht dot file uploader, here I'll write upload XML file. Okay, and then I need to provide the type that I want to use. My type would be, under the third bracket, I need to provide the extension XML. Okay, and now for the PDF one, I'll just copy this, paste it over here. I'll change the name from XML to PDF, and here I'll change it to PDF, and I'll change it to PDF. Okay, all right. Now if uploaded XML file and uploaded PDF file is there, then and only I'll showcase that uploading had been success. So uploading is success, ht success, I'll use both files uploaded successfully, right? And then I'll do an if check. So if ht dot button, here I'll provide start validation. If someone click into that button, and then I need to simply call the function. So I have this run comparison function where I'll simply pass my uploaded PDF file or my XML file and my uploaded PDF file. Okay, or else if I don't have any uploaded file, then I need to provide an information that please upload files. Okay. All right. So now what I need to do, I need to activate my environment. So my env slash scripts slash activate. I need to get into my XML validator. So XML Role Validator. Then to run this, I'll use Streamlit run app.py. Okay, run it. And let's see. So all right, so I'll come in my downloads in this folder and I'll upload this define roles XML file, and I'll come over here, I'll upload this one. All right, then I'll just write my validation and I'll see my process started. Okay, now let's create the main backend logic to it. And saying backend logic mean we simply need to add up all those modules to create a pipeline for my application. Okay. All right. So as we have done this before in my main.py where we have simply added all my modules. So I'll just simply copy the file, paste the file over here. Okay, and I'll just explain you the bit. So all right, so what we are doing over here, that we are doing this optional cleanup Pinecone thing. So we are cleaning Pinecone index for a fresh start that we have also done in our main.py. So you could see we are checking that if the index name is already exist or not. If it does, we are simply deleting that index again, and we are creating an index from the scratch again, and we are using this time.sleep to give our Pinecone some time to process the deletion part. Right now we need to add all our roles. So the first role was to extract roles from our XML files. Our second was to initialize our RAG PDF extractor using this RAG PDF extractor class. Then we need to process the PDF and extract the roles. Then we has to compare our roles. Then we have to generate our reports, and then that's it. Here is how you'll be getting your report. And there is some normal UI that I've done over here for the clear markdown process. Okay, so that's being said, I'll just save it and I'll just run this again. Alright, so now test this application finally. Okay, so I'll add my define roles. I'll add my document with roles. I'll simply click on the start validation. Okay, you could see Pinecone index management, index role comparison index already exists, so deleting for a fresh run. Okay, index role comparison index deleted, waiting a few seconds for a full removal, proceeding with the new index creation. Okay, so I have just simply added those markdown for a better interface, or so that every user understands very well. Okay, so extracting roles from XML, you could see we have these roles in our XML files. If you want to check it, I can show you that. You could see we have 6-1: software engineer, project manager, senior developer, QA tester, business analyst, and our data scientist. We have software engineer, project manager, all those 6 over here. Okay, then initializing PDF extractor and Pinecone, processing PDF and extracting rows via Gemini. You could see in our PDF we have more than 6. We have actually 11. Here you could see in my role comparison report we have 6 in XML and 11 in PDF. Now roles matched XML to PDF. business analyst, data scientist, project manager, QA tester, senior developer, software engineer. So incorrect PDF roles are these four. So the conclusion are that roles in PDF are incorrect as there are roles that do not match in the XML file. Now let us do one more thing to check to convert this incorrect flag to correct. What we need to do, we need to simply change our XML file, right? So we'll come into my XML file. I'll just copy this. I'll paste it 4 times. Okay, and I'll just add them to make it correct. Okay, so let me just add them here, here, and project owner here. All right, and I'll cut them. That's it. Okay, you could see we also got our response over here as well. All right, so let's try that, and I'll upload that now. Okay, so define roles, my document with roles, and I'll use my start validation. Let's see what happens now. Okay, so you could see we have extracted the roles, we have initialized our PDF extractor and Pinecone, process our PDF and extracting rows via Gemini, compare rows. Now here you could see that total unique roles in XML, total unique roles found in PDF 11. So rows matched XML to PDF, these all are matched, and we are saying all roles found in the PDF match in the XML definition. Okay, or no rows were found in PDF. All rows in the PDF are correct according to the XML definition. Alright, so that was our application, and thanks for watching.